Comes on everyone. Let's start off. The last thing that we did was the images and stuff. Great. Now, before going ahead, there are a few things. I think I wrote a formula wrong here. Yeah, there's supposed to be a minus sign. Minus V by U. Magnification. I forgot a minus sign. That was one. And there was one question in current I gave you as a homework, but we never discussed it. This question. Did anyone try this? Completely forgot about it. Arya is reminded. Anyone got an answer for this? You guys remember this question, right? So how do we do this? Look at this carefully. So start from the center. So let the potential at the center be 0. Now this current is 1 ampere and that is 1 ohm, right? So what is the potential difference? V is equal to IR. 1 into 1. The potential difference is 1 volt. Current is going from here to the center. So that should be a higher potential. So this will be plus 1. This current is going away. So this should be minus 1. This should be minus 1. Is that making sense, everyone? Current always flows from higher to lower potential, and the resistance is 1 ohm, and the current is also 1 ampere. So the potential difference must be 1 volt. Now, if this is minus 1 and this plus 1, then the potential difference is plus 2, and the resistance is 1. So in this branch, the current is 2 ampere, and in this branch, the current is 2 ampere. If this is 2 and 2, the same way, I can also argue here, this would be plus 1, and this would be minus 1. This would be 2 ampere. This would be 2 ampere. That means in this branch here, so this is 2, this is 2, and this is 1. The total that is 5 ampere. So in this branch, we have a current of 5 ampere. That means this point is plus 6. Similarly, this branch is 5 ampere on the left-hand side here. This is also plus 6. Aaron is getting it so far. You're getting how you're getting the potentials there? Now look at this thing here. So from here, we are getting 2. We are getting 2 here. And 1 is coming from here. So that means this point is minus 6. So 5 into 1 is 5 volt, and the current goes from higher to lower. So it is going from minus 1 and minus 5 to minus 6. Now, if this is plus 6 and this is minus 6, that means the potential difference is 12. In this branch, we have 12 ampere. In this branch, we have 12 ampere. And in this branch, we have 5 ampere because this was 2 and this was 1 and this was 2. So now 12, 12, 24, and 5. In this branch, we have 29 amperes. So that's your answer. So current in the AB branch was 29 amperes. How did we do this again? I'll show you one more time. Listen carefully. Start from the center. This is 0. This is plus 1. This is plus 1. This is minus 1, the green one. So this will be 2 ampere. This will be 2 ampere on the right hand side. So 2 and 2. Because this is also minus 1. So if the current is coming towards the origin, it should be higher. If the current is going away from the origin, it should be lower. If that is 2 and this is 2 and this is 1 ampere here, so this branch should have 5 ampere. If this is 5 ampere, this is plus 6. The same logic I can use here, 5 ampere, this is plus 6. If that is plus 6 and this thing would be 2 ampere and this thing would be 2 ampere and this is 1 ampere, so this thing is 5 ampere. This branch A here is minus 6. So plus 6 minus 6 will give you 12, and this will give you 12, and there is already 5 coming from here, so that should give you 29. Is that clear, everyone? It all comes with the nodal analysis there. So do try it on your own again. It's you just have to put 0 and you have to get the potentials and keep solving. So yeah, you can fold it and do all that stuff, but yeah, the same stuff. When you said this is 6 and this is 6, indirectly you're saying it is symmetrical, right? So when you fold, you'll get the same thing. So got this? So that's how you can solve this. It's a good one. So not difficult, but when you see the question, it does look scary. So let's get back to the ray optics there. So these are the three formulas that you have: 1 by v plus 1 by u is 1 by f, and f is r by 2, and magnification is minus v by u. Right. So great. Let's go ahead with a few more questions. So last thing that we did was tracing of images and this formation of images. Perfect. So we'd say we have a mirror and we have a mirror. So we have a convex mirror on the left and the concave mirror on the right. So both have same radius r and r. Let's call this thing mirror 1 and this is mirror 2. So from this pole to this pole, at the center, we have an object. This distance is r and this distance is r. Find the position of the images after 2 reflections. Look at the word 2 reflections means what? So first light rays will hit M2, then they will fall on M1, then you'll get an image. So I want that image. Light rays will go from object to M1, then they'll hit M2, and then they'll form an image. I want that image. So after 2 reflections where they meet or appear to meet, that is the image. Because if you ask you find the number of images, there'll be infinity. The light rays will just keep bouncing between them. So give me the position of the images which form after 2 reflections. So first to do M1, M2, then do M2, M1. Yes, sir. Let's see. We have some answers. Oh, Nere. Minus R by 3. Okay, that looks right somewhat. Let's see that. Okay, let's see M1, M2. First, we will do M1, then M2. Remember, this is what I told you in ray optics. When you do one mirror, you don't care about the other guy, right? So you do one at a time. Nay, Param, I think you got one wrong. So the first thing, first you're hitting M1. Where is the object? At the center. So image should form at the center, but let's calculate, just for the sake of it. Let's calculate it. So what is U? Remember, lighters are going to the right side, so right is positive. So I'll always write the sign convention. So U is minus R. Focal length will be R by 2, but R is radius is also negative, so this is minus R by 2. You wanted to find V. So apply the formula 1 by V plus 1 by U is equal to 1 by F minus 2 by R. So we get V is equal to minus R. So minus indicates image is forming on the left hand side. So these light rays are going and hitting the mirror, and they would retrace the same way and they're coming back to the same place. So technically I know this already, but yeah, I wanted to show you, that's it. So this is the image. So for the M1, the light rays will hit M1 and come back, but this is not the answer. This is only one reflection, isn't it? Now the second reflection. So this I1 will act like an object. So now from here, light rays are hitting here and they're bouncing off. So this mirror M2 will think I1 is an object. It does not know who is O. Now again apply the formula. Light rays are going towards left side, so left is positive. Whenever you get confused, always write what is U, what is R. That will make your life easy. So what is U here? The U is minus R because this distance is also R. What about the radius of curvature? Look at this thing. The center is on the left hand side. So, and left is positive. So your focal length is plus R by 2. Apply the formula 1 by V plus 1 by U. Anyone is confused with the sign convention, please ask. Then we get V is equal to plus R by 3. Plus indicates it is in the direction of the light rays. That means if you extend it backward, this is where the image forms, I2. This is your one answer. So when the light rays hit M1, then hit M2, the final image will form R by 3 on the left hand side. Is this clear, everyone? This is what I mean by two reflections. Right, Samyak. Now, what about the other part? Now we will do M2 and M1. Now, luckily for M2, right, this itself is the second part in the first part was the second one. So we will do M2 and then M1. So if you see, there's really nothing much to think. You just take the formula and keep applying. So first you are hitting M2. This is your object. Latest will hit a bounce. This we just now saw. This would be I1 and this would be R by 3. So we saw it just now, so I'll not do it again. Now for the second part, this is your concave mirror. This is the idea that tomorrow I'll put a lens, I'll put a prism, I'll put everything. This is what you do, one at a time. We don't care what the other guy is doing. So now your I1 is an object, and this distance would be how much? Remember, initial distance was 2R, and now you have an R by 3 extra. So 2R plus R by 3. That was 7R by 3. Light rays are going towards right, so right is positive. So U is minus 7R by 3. Radius is negative because the center is on the left hand side. The focal length is minus R by 2. Apply the formula 1 by V. 1 by U is minus 3 by 7R. Minus 2 by R. Minus 2 by R. 3 by 7R. That's minus 14. Minus 3, 11. 7R by 11. Minus 7R by 11. Minus sign indicates the light rays are coming and meeting at the front. This is your I2. And this distance was your 7R by 11. That's your second image. Are the steps clear, everyone? That is how you do. If you have multiple mirrors, you do one at a time. You hit M1, then get M2, then M2 and M1, and you keep doing it. Any doubts on this? Clear? Next thing. Now, last time, right? We have seen the equations and stuff, but if I want to draw a graph, let's say if I'm drawing a graph for a concave mirror, so listen to this thing. This would be can be a question. If you're plotting a graph between V versus U graph, how do you think the graph will look like? Be careful, you have to do with the sign convention. If you're drawing a graph between V and U, U is your object distance and V is your image distance. So plus U indicates U is the object distance. For a concave mirror, the object is always on the left-hand side, so that will be real. So if the object is on the right-hand side, it is a virtual object. This thing is your real object. If U is negative, the object is real. If V is positive, it is a virtual image. If V is negative, it's a real image. Basically, we are using this convention. So this is your origin. Anything this side is positive, anything this side is negative, right? So that's the object and stuff. And if you see the equation there, the equation is 1 by V plus 1 by U is 1 by F. This is actually a rectangular hyperbola. So in case you don't know, that's an equation of a rectangular hyperbola. Can you try to draw? I'll give you a minute or two. Let's whatever you think. How will the graph look like? It doesn't really. It's curvy. That much I'm sure you figured out. There are no straight lines. The 1 by V plus 1 by U, and you want V and U ka graph. So one thing is it is curved. And don't worry about the exact curve. The important thing is the points. How will it look at infinity? How will it look at focal length? How will it look at center? Think. Take a minute or two. Then I'll draw one, and then you can see how much you figured it out. Like I keep saying, whenever you get graphs in the exam, the easiest thing to do is eliminate options. Okay, let's see. So what are the important points? When you're at infinity, when the object is at infinity, image will be at focus. When the object is at center, image is at center. When object is at focus, image is at infinity. When object is at pole, image is at pole. So these are few things which you should know. So this is minus 2f. This is minus f. This is minus f, and this is minus 2f. minus 2f is the center because 2 times focal length will be radius. Okay, great. So start like this. When u is minus infinity, that is here, v is minus f, isn't it? When object is at infinity, image will form at the focus. But where is the focus? On the left-hand side. That is minus f. So your graph should start somewhere here. When object is at the center, that is 2f, image will be also at the center, 2f. That means your graph here should pass through this point here. So this would be a curve passing through this point. This is your center. And when as the object approaches minus f, that means as the object comes towards the focus, image will go to minus infinity. The rays will become parallel. So this would go like this. So they will tend towards this line. So is that left part clear, everyone? You have to pass through the center. When u is minus f, v will become minus infinity. When u is minus infinity, v will be minus f. I hope that was clear. Now, what happens once you cross this? The moment the object crosses the focal length, image becomes virtual. Remember? So that's the reason you should know those 6 images. Now, once you become virtual, but remember, you're still at infinity, so image will be at plus f. If you remember this picture here, can you see this arrow 6 is at plus infinity? So the graph here will start from here. And as you get closer and closer to the pole, the object and the image will meet at the pole. Now, if the object goes inside, means it becomes a virtual object. You know how a virtual object looks like? See, everyone. For example, let's say you have a lens here. We have an object here. Let's say the light rays hit the lens, and these light rays were supposed to meet here. Meaning, if the mirror was not there, the light rays would have gone and they would have met here. You're getting it? So this I1 is an image of the lens, but it is a virtual object. So now the light rays will bounce here and they'll go somewhere here. You're getting this? So for mirror, so that is the meaning of virtual object. It doesn't mean there will be some object or something. It was supposed to meet there, but you blocked it. If the mirror had not been there, you would have gone and met at I1. So for mirror, this I1 is a virtual object. The light rays was supposed to meet there, but you didn't let them meet. So rays were supposed to meet at I1 after passing through lens. So remember this thing. This is the meaning of a virtual object. There's nothing there. Clear? So people get a feeling like, oh, how does a virtual object look like? It doesn't mean there's an object behind the mirror. That will never create an issue there. So whenever you put something in front, where the letters were supposed to meet, it's called a virtual object. So same thing. So if the object again goes to plus infinity, then the light rays will become again parallel. So again, it will become like this. Is that clear, everyone? So when the object is at minus infinity, light rays have become parallel. When the object is at plus infinity, light rays again have become parallel. So after crossing the pole, it's all virtual and then it just goes off. Clear with this? So on the right hand side, that is the meaning. This is a virtual object, meaning the light rays were supposed to meet after the mirror, but the mirror came in the middle. So they will form a real image. So you can see here, U is positive, but V became negative. Is the graph making sense, everyone? This is how it would look. Now, can you guys draw for convex mirror? You try. I'll give you a minute out. Idea is the same, but remember the convention is different. The pictures are a little different. You try for convex mirror. You just draw whatever you think. I'll show you in a minute. This is some little non-standard. Generally, people don't draw VU graphs because they really don't look that great. show you. Keep drawing. I'll take another minute to put the whole thing. So this is positive. This is negative. So again, what are the important points here? Yeah, problem here is there's actually nothing much for this convex. You don't have, there are only two pictures if you remember. If you're at infinity, the light rays will appear as if they're coming from the focus, but it is on the plus F. So here the focus is on the plus F. If the light rays fall at the focus, I think then they'll become parallel. So technically, there are only two things here. Great. So U is minus infinity, then V is at plus F. So the graph starts here. And then, yeah, as we keep getting closer and closer, the object will get closer and closer to the pole, and you'll meet at the pole. So this is how it looks. When the object is at the pole, image is at the pole. These are the 2 points. So when U is minus infinity, it is plus F. This is the pole. And then if you keep going, you will get closer to this guy. And then once you cross this, image will become, yeah, it kind of looks like this. It kind of looks like a mirror image of this. If you see the first and the third quadrant, it gets reversed a bit. But that's how the image looks. So unlike a concave mirror, you really don't have too many variations in this. There's like either the light is a parallel or this. That's it. Clear with this? And that's how your BU graphs will look for concave and convex. So be careful with the sign convention. Even if you use your regular Cartesian coordinate system, the graph will still look same because we are taking right positive, left negative here. Now, other than this, if you go for exam like CET and stuff or mains also, they will try to keep your graph simple. 1 by V plus 1 by U is 1 by F. So instead of drawing V and U graph, what if I draw a graph for 1 by V and 1 by U directly? This keeps your life easy. So now then this function looks like x plus y is equal to constant. So this is a straight line. Now for a concave, think about it. For a concave, U is negative and V is also negative. So the graph should be in the third quadrant. For convex, when the object is negative, image is positive. That means when 1 by U is negative, 1 by V is positive. So the graph will be in your second quadrant. That's how it could kind of look like. Clear with this? Again, you have to be careful with signs. Here, V and U will be taken with sign convention. It's a straight line, but the quadrants will be different. All clear with this? These are the easy graphs, the straight lines. Next thing. So till now, we have seen what objects, how to find the images when the object is on the principal axis. Now, let's not put them on the principal axis. So these graphs themselves can be treated as questions. So let's say we got an object. This is your principal axis. R is 20 centimeters. Object is here at a height of 2 centimeters. And let's say this distance is 30 centimeters. How do we do this? So listen to this thing. I'll show you the process. Step one. So whenever object is not on the principal axis, you cannot use the formula because that u, v, and all are the distances measured on the principal axis. So what we do, we drop a perpendicular. Drop a perpendicular from the object to the principal axis. Let's call this thing O dash. I like to call it a shadow. So something like that. So from here, if you drop a perpendicular, this will be O dash. The idea is simple, Ray. See, if you go and stand in front of a mirror, if I can find the image of your legs, shouldn't your head also be on that same vertical line there? You're getting the idea there. I cannot find the image of the head, but I can find the image of your legs. Wherever your legs are present, your head also should be in the same position, but maybe at a different height. So I don't know how to find for O, but I know how to find for O dash. Step 2, find image of O dash. Step 3, then use a magnification formula. So the idea here is the actual image lies on a line perpendicular to principal axis and passing through the image of O dash. Step 4, use the magnification formula. M is equal to minus V by U, which is height of the image by height of the object. Right? So let me show you the process. Step 1, drop the perpendicular, that is O dash. Let's find the image for O dash. What is U? Light rays are going to the right side, so left is negative, U is minus 30. Radius would be minus 20. So therefore, focal length will be minus 10. So 1 by V plus 1 by U is equal to 1 by F. It will go that side, that will be minus 15 centimeters. That means this image here will form somewhere here, I dash at 15 centimeters. Great. Then use the magnification formula. M is equal to minus V by U, which is nothing but height of the image by height of the object. V is minus 15, you have to take with signs. U is minus 30. Height of the image and height of the object is 2. Remember, anything above the axis is positive, below is negative. From here, we get height of the image will be minus 1. So that means the image is at a height of 1 centimeter from the principal axis, and minus indicates it is downward. So from here, the image is somewhere here. This will be O dash and 1 centimeter below the principal axis. So if you ask the image coordinates, it is minus 15 and minus 1. Is that clear, everyone, what we did? This is the image I, and this would be your I dash. Clear what we did? So the only new step you learned is drop a perpendicular. The story is the same. End में whatever you get V का value, you have to put it in magnification and figure it out. All clear with this process? Now you guys try this. We got a convex mirror, radius R. In front of this convex mirror, we have 4 objects. A, B, C, and D. So there are 4 points there. This distance is R. Distance between C and D is also R. This distance is A, and this distance is A. So this ABCD will actually form a rectangle. So there are 4 points like this. So these 4 points will form 4 images. And we can take A is much, much less than R, so that light rays will be paraxial. So these 4 points will create 4 images. Now, if you join the 4 images, you get a quadrilateral. Find the area of the quadrilateral. Don't worry about the area. Simply, I'm asking you, find the image, 4 images. Find the area of the quadrilateral formed by images of ABCD. There, let's get this. Hope the question was clear. There are 4 points A, B, C, D. They'll create 4 images: A dash, B dash, C dash, and D dash. If I join all these 4 points with straight lines, you will get a quadrilateral. What is the area of that quadrilateral? Even though it looks like there are 4, in reality, you have to just find for A and B. C and D will be same in the reverse. Try, give it a try. Give me a minute or two. Let's see. 39A square by 144 near Reparam. That looks right, Arya. Samyak, you are missing a 2. Kanksha, you're also missing something. Okay, let's find this. First, let's get, see, the question is all about images, okay? So let's find the images for each one of them, and then we are done. So let's find for B and A. If you can find for A and B, your job's done, actually. You can figure out from there. So let's find for A. So what is U? Minus 2R, because the distances 2 are there. Focal length is R by 2. Apply the formula 1 by V, 1 by 2R minus sign, and 2 by R. So we will be 2R by 5, right? And the magnification will be minus V by U. So minus 2R by 5 by minus 2U, minus 2R. Signs are important. That would be 1 by 5. That means the height of the image becomes 1/5. So for A, the image will be at 2R by 5 and at 1 by 5. Let's find for B also, then I'll drop both together. For B, U is minus R, F is R by 2. So 1 by B plus 1 by minus R is 2 by R. B is equal to R by 3. Magnification would be minus R by 3 pi minus r, 1 by 3. Perfect. So the plus sign indicates the image is erect. Uh, and the distance is 2r by 5 is 0.4 and r by 3 is 0.33. So B is closer. So B is closer and B is also higher. So this is B dash and this is A dash. They're not on the same height. This height will be A by 3, A by 5. And this height will be A by 3. Now, from same logic, because B is exactly below the C is here and D is here, if I actually join them, I get a rectangle. Exactly below this, you will get D dash. Below this, you get C dash. If you join them, you actually get a trapezium. Can you see that? So, and what about this distance here? This distance was r by 3 and this distance was 2r by 5. So what you got is a trapezium whose this height will be 2a by 3 because a by 3, a by 3. And this side is a by 5, a by 5. So this will be 2a by 5. And the distance between these two will be 2r by 5 minus r by 3. That is 6 minus this thing. I think that's r by 15. And everyone knows the area of a trapezium. So a rectangle becomes a trapezium. Half into sum of the opposite sides, 2a by 3 plus 2a by 5 into the base, r by 15. That's a by 3, a by 5, 8a by 15. That would be 8ar by 225. Yeah, that's your answer. Is that clear, everyone? Again, what did we do? We just use the formula, getting it? So that's what I'm saying. It is brute force. Unlike mechanics, right? You really need to think very less here. There are very few questions where you can actually think. Normally it is this way. Now, the thing is, why didn't I give us simply a rectangle? What is the problem? I could have done this way, right? You have to be careful there. So don't be that misconception. If you put a rectangle, I'll get a trapezium. No, that is wrong. Instead of this, if I had kept a plate, how do you think the image will look like? If this was a rectangular plate, the image would be different. These two would be like this. These two would be like this. This would be a curve. Remember this question? Dekho, I told you this thing. When you're going straight line, did you see how the image was traveling? When this guy is going in a straight line, the image is actually going in a curve. So if I had given a rectangular plate, you won't get a trapezium. You'll get a shape like this. And I don't know how to find the area for this. This is B dash, this is A dash, this is C dash, and this is D dash. So be careful with that. It won't form a trapezium. If you put a rectangular plate, you won't get a trapezium. So what I did smartly, I said there are 4 points. You got 4 images. So when you join them with lines, yeah, now it becomes a quadrilateral. It worked out. Are you clear with that? So 4 points and a rectangular plate are not the same thing. Let's see one more on this. I'm keeping all these questions together. Radius of curvature r at a distance of 2r, we have a particle which is going in a circle with speed u and radius a. Again, a is much less than r, so that raise up our actual. The principal axis is perpendicular to the plane of the circle. Are you getting how is the motion? This is the principal axis and this is the circle. Are you getting it? It is not like this. It's the principal axis is perpendicular to the plane. principal axis is perpendicular to the plane of the circle and passing through the center. Find the speed and the acceleration of the image. So the particle is moving, even the image will move. I don't want the position. I want the speed and acceleration of the image. Yeah, let's get this. Yeah, those curves are actually hyperbolas. Finding area is a mess. You find the equation, then get the area and all that thing. It's a messed up thing. Let's get this. Hmm, looks right, Arya. नहीं परम. Srihari, that is for plane mirror. These are curved mirrors. नहीं Samyak. Let's see. Can you guys tell me one thing? What remains same for the object and the image? There is something same. What remains same for the object and the image? They take same time period, isn't it? They take same time to complete one revolution. They have same time period. They have same omega. They have same angular velocity. That was the catch in the question. When the object completes one circle, image also has to complete one circle. So same story. I'll drop the perpendicular for this guy. That would be O dash. So 1 by V, 1 by U, U is minus 2R, F is R by 2. Now see, I stopped writing that signs also. So you should get used to it. Then V would be 2R by 5. The magnification would be minus V 2R by 5 by minus 2R. That's 1 by 5. That means the image is going in a circle of A by 5. The speed is V dash. Now, then we will say object and image will have same angular velocity because they complete one revolution in same time. So same angular velocity. So omega was U by A and omega was also V dash by A by 5. So from there we get V dash is equal to U by 5. So because the circle is smaller, you will go slower. And what about the acceleration? Anything that goes in a circle will have a centripetal acceleration. Even though the image is not real, it does have an acceleration. which is omega square into radius. So omega is u by a whole square, and the radius of this circle is a by 5. So that would be u square by 5a. Is that clear, everyone? Again, so same story. If you see, the only thing that we did was found the radius there by using the magnification, and then we brought circular motion into this. I hope all are clear with this kind of questions. Making sense? So if the object is not on the principal axis, drop a perpendicular, get the image of the foot, and then use magnification and get this thing. This is one type of problems there. And like I said again, whatever techniques you are learning now in mirrors, exact same things you will learn in lenses. The formula is different. The next one, this is the most important part. The next part, again, we'll do them as one cluster. In mirrors, if they want to ask you something in advanced based questions only on mirrors, like this is the thing they can play around with. Let's start off with simple thing and then I'll slowly increase the difficulty. So let's say we got a mirror here. R is 20 centimeters. We got an object here on the principal axis. It's coming towards the mirror with 2 centimeters per second. And this distance is 30 centimeters. Mirror at rest. Find the velocity of the image. At this instant. So when the image is at a distance of 30 centimeters from this mirror, what is the velocity of the image? Let's see. We have different answers. Okay, let me show you one. Now, how do we handle this? You can't say the image will go at the same speed. So 1 by v plus 1 by u is 1 by f. So listen to this carefully. Differentiate on both sides. We have done this before for that small images, if you remember. This would be minus dv by minus 1 by v square dv by dt. Differentiate with respect to time. Minus 1 by u square is du by dt is minus 1 by f square df by dt. Here f is constant. Later on, I'll show you cases where f also changes. So then you should go back to the basic derivation. Like you can't remember the end result. Now, when you arrange these terms, you end up with dv by dt is equal to minus v square by u square du by dt. Till here it is great. Now here there is an important thing you need to understand. What are u and what is u and what is v? If you see, u is the object distance with respect to the pole. And this is the distance which you measure with respect to the pole. That means if the mirror itself is moving, then du by dt is not your velocity of the object, but it is a relative velocity. V is the image distance from the pole. All these distances are measured with respect to pole. That means the observer is standing on the mirror and is looking at this. So when you say du by dt, this is the velocity of the object with respect to the mirror. That is the catch. Now, luckily in this case, the mirror is not moving, so it won't create a problem. But if the mirror moves, and this is the mistake people do. So this is the velocity of the image with respect to mirror. So be careful with that. The du by dt and dv by dt are not the velocity of the object and the image. And what about the sign convention? Velocities in the direction of the incident rays are taken as positive. We still follow the same sign convention. If the velocity is in the direction of incident rays, it is positive. Velocities in the direction of incident rays. Are taken as positive. So this formula is actually velocity of image with respect to mirror minus v square by u square velocity of object with respect to mirror. These all are relative velocities. So this can be also written as velocity of image with respect to mirror. And you know what is v by u? Magnification. So this is minus m into m square velocity of object with respect to mirror. Because v by u is magnification. So yeah, that's your main formula there. Again, valid only if f is constant. If your f is changing, this formula is also wrong. So don't remember this blindly. Now, getting back to the question. So one thing is clear, we still need to find u and v. So let's find that 1 by v plus 1 by u is 1 by if minus 10. So v would be minus 15 centimeters. So I need this data. Right, now, getting back to the question. So what is the formula there? Velocity of the image with respect to mirror is minus v square by u square, velocity of object with respect to mirror. So v is 15 ka square, u is 30 ka square. The object is going which way? Right side in the direction of light rays, so plus 2. So that would give you minus half. The minus sign indicates the image is going backward. So the image is at 15 centimeters and going backward with an half centimeter per second. The minus sign indicates opposite to the light rays. Is the process clear, everyone? So you will get your u and v as usual. And then once you get that, you just need to take it and dump it in this formula. But all these things you got are with respect to the mirror. If the mirror is not moving, then it is fine. Any doubts on this? All got this? So now you try this thing. Let's say we have a convex mirror, 20 centimeters. The object is here. Let's say it is going with 1 centimeter per second. The mirror itself is going with 2 centimeter per second. And this distance is, let's say, 20 centimeters. I'll keep it simple. Now find the velocity of the image. Now see, if they simply say find velocity of the image, they're asking the ground frame. They won't tell you every time. If they don't mention anything, it is always in the ground frame. Let's get this. 11/4, 7/3. Let's see. First get the image. 1 by V, 1 by U, 1 by F. F is 10. So V is equal to 20/3. Now, the important thing, remember, these are the velocities with respect to the mirror. So stop the mirror. That's the whole idea, that couldn't stand on the mirror. So if the mirror will think, so if you stand on the mirror, I'll put a small picture there. Mirror will think, okay, I came to rest, and it will think the object is coming with 3 centimeter per second. This was your velocity of the object with respect to mirror. This is VOM. That's what the mirror thinks. Now apply the formula. Velocity of image with respect to mirror is minus V square by U square. Velocity of object with respect to mirror. V is 20/3 ka square. U is minus 20 ka square. This guy is plus 3 because it is going in that direction. So we get velocity of the image with respect to the mirror is minus 1/3 centimeter per second. Means it's going backward, minus 1/3 I cap. So velocity of image with respect to the ground frame will be velocity of the image with respect to the mirror plus velocity of the mirror with respect to the ground frame. So this is minus 1/3 backward, and the mirror is also going backward, minus 2 I cap. That would be minus 7/3 centimeter per second I cap. It's going backward with 7/3. Is that clear, everyone? So that's one additional there. You have to be careful. I hope you can see how things added up, finding the image. Then it is stop the mirror. If you remember, that's how we did. I told you this multiple times. Whenever something is moving, stop it. Lens is moving, stop it. Mirror is moving, stop it. Then solve the problem in that frame and then get back. You can't do it directly in the ground frame. Is this clear, everyone? All got this? We will bump up the level now. This would be a still, if you ask me, this would be a mains level ka higher level question. Advanced is an easy one. We will push it one more level. Take a break. Come back by 9:45. We'll continue from here. Any doubt so far? So come back by 9:45. Yeah, camps on everyone. Let's start up. Let's see a variation of it. Now we saw this thing. I'll keep the data same. So R is 20 centimeters. This time the object is going with 2 centimeter per second above the principal axis. Let's make it 1, and let's say this is 2 centimeters. Yeah, I can move the mirror also. Let the mirror also go with 2 centimeter per second. And this is also 20 centimeters. So the object is going above the principal axis. Now find the velocity of the image. We'll do something. Let's keep the mirror at rest. Let's get this. Idea is the same anyway. In the end, you have to add it back to this thing and all, but let's get this thing. What if the object is going above the principal axis? Okay, let's see how to do this thing. So what's the issue there? First, let's find the image distance. So if you drop the perpendicular, that story is still the same. So 1 by v plus 1 by minus 20 is equal to 1 by 10. I kept the data same. So this is 20 by 3 centimeters. Perfect. Now, when you apply that formula, velocity of image with respect to the mirror minus v square by u square, and this is velocity of object with respect to the mirror. This is all for O dash, okay? So basically, this gives you the x component. This is the component of velocity along the principal axis. This is not the full velocity because you're finding the image for O dash. So this is the image for I dash. This is a component of image velocity along the principal axis. So actually there are two components now. And you know why, right? If you remember, we drew the picture. If you remember, it was going like this. It is going in a curve. If this thing goes in a straight line, the image will actually go in a curve. So yeah, substitute the values here. V would be 20 by 3, that is 20 minus 1 by 9. So this is minus 1 by 9 centimeter per second. I can. So this is only the I component. All clear with this? No, there is also a vertical component. How do we get that? We get it from magnification. If you remember, magnification is minus V by U is equal to height of the image by height of the object. So we get height of the image will be minus h naught, height of the object by V by U. So if I differentiate this dhi by dt, this will give you the vertical component. So the vertical component of velocity is the rate of change of height of the image, because hi is the distance of the object from the image from the principal axis. Now when you differentiate this, h naught is constant, v by u got differential. So this is 1 by u dv by dt. I'm using the product rule. And then v minus 1 by u square du by dt. Yeah, it doesn't look that great. So, but what is h naught ka value? H naught was 2. U was minus 20 sines. dv by dt is this guy. This was your dv by dt, which was the velocity with respect to the mirror only, which was minus 1 by 9. Minus v is again 20 by 3 whole square by minus 20 ka square, and du by dt was plus 1. This is minus 2 plus 1 by 180. 120 will cancel there. Minus 1 by 60. Multiply 3 there. 180. 1 minus 3. Minus 2 by 180. Minus 1 by 90. Minus 1 by 40. Plus minus plus 1 by 45. Check out. So this is your final answer. So this is how the image was going. So the image ka position is 20 by 3 and the magnification was 1 by 3. So the object is somewhere here, the image at a distance of 20 by 3, and the height was 1 by 3. And this has a velocity going backward 1 by 9 centimeter per second, and it is also going upward with 1 by 45. So it's actually going at an angle. Is that clear, everyone? Do check the calculations. I could have goofed up. And if you see, the headache was you have to be careful with the signs. All you need is one sign messed up and the whole thing will go for a toss. So 3 by 180 minus 2 by 180. Yeah, it's 45. All clear with this? So you get the y component from magnification. Now, what if in this question, what if instead of going like this, what if this is going this way? then what do you think would have happened? The object, if it had gone this way, what do you think would have happened? Then even h naught is changing, isn't it? Then you have to differentiate d h naught by dt also. H naught will not remain constant. You'll get a triple differential. You have to differentiate h naught, v, and u separately. Clear this. Let's see one more like this, a little more simpler, but the idea is the same. I'll keep the values same again. R is 20 centimeters. At a distance of 20 centimeters, we have an object. But this time, this object is going straight up. 2 centimeters per second perpendicularly. Find the velocity of the image at this instant. This is a good one. Calculations are slightly less. So this guy is going straight up. And others, do keep your cams on. Two by 3. Okay. So let's see. First thing, du by dt is 0 here. So there is no horizontal component. So 1 by v plus 1 by minus 20 is 1 by 10. So v is equal to 20 by 3. So this is all great. So if you do velocity of image with respect to mirror is equal to minus v square by u square, velocity of object with respect to mirror. So this is for I dash and O dash. So these are basically the x components. These are components along principal axis. This is 0. So therefore Vx is 0. There's nothing to do there. So V vertical is simply dhi by dt. And hi is nothing but hi by h object is equal to minus v by u. Here understand, u is not changing. U is constant here. When it is going up, u is not changing. H naught is changing. So this would be minus h naught v by u is का differential. Minus 1 by u will come out, and then we differentiate dh naught by dt. This is what I was saying. I could have changed u also. into V plus H naught into dV by dt. But interestingly, dV by dt is also 0 because this guy is dV by dt. There is no velocity of the image in the x direction, so this term was also 0. You're left with U is minus 20 and d h naught by dt was plus 2 and V ka value was 20 by 3. 20 goes off, minus minus goes off, you get 2 by 3 centimeter per second. J cap. So the image is at 20 by 3 and it is going up at this instant. All clear with this? All you need to do is make this thing go at an angle of 45 or 60 degrees, and then suddenly the problem becomes deadly. Everything will start coming up. U will come, Vy will come, everything will come. But all clear with this thing. So when you say du by dt, dv by dt, understand one thing: u and v are distances on the principal axis. They are giving you only the x coordinate, I caps. They never talk about j components. Is that clear, everyone? U and v are the distances on the principal axis. Clear? Any doubts on the calculation? You should definitely try these things on your own again. So I kept all of them together at one place, so you can figure it out. Next thing, Newton's formula. Now, if distances are measured from the focus instead of measuring from the pole, sometimes you get questions like this also, especially in CET. So this is the object, this is the image, this is the focus. Let's say the distance are measured like this. So let the distance be x1 and let this distance be x2. Or maybe x and y. Let me take it as that. So x is the distance between the object and the focus, and y is the distance from there. Now, when you apply the formula, u will be minus of x plus f. V will be, because the distance are measured from pole, so this would be y plus f. Just go and put it in the formula. 1 by v, that is minus y plus f. 1 by u minus x plus f. And here the focal length is negative, so plus 1 by minus f. Simplify this, you end up with x plus f, y plus f into f is equal to xy plus xf plus yf plus f square. Cancel everything, you end up with x into y is equal to f square. You get a very good result. So it's pretty easy to remember. There have been a lot of questions on this. If the distance of the object and the image from the focus is 5 and 10, find the focal length. Ho gaya question. Now, how will you do this if it was a convex? In case of a convex, this was the focus, this is the object, this is the image. The story is the same. So this would be y and this would be x. Now, if you notice something, since f square is positive, x into y must be positive. That means x and y must be on the same side of the focus. If they're on the either side of the focus, you get a negative. So this is one good theoretical question. The object and the image will always form on the same side of the focus, meaning either both will be this side or both will be this side. You can't have an object and image and focus in the middle. So in case of mirrors, object and image should be always on the same side of the focus or on same side. Yeah, Newton keeps popping everywhere. And that's what happens when you don't have internet and Instagram and all. You sit and start making different concepts and laws. All clear with this? That's about mirrors. So we have done plane mirrors, we saw images, and we saw spherical mirrors, and then we saw moving and everything and stuff. The next thing is refraction. So what is refraction? The bending of light rays at the interface of two mediums. So whenever light goes from one medium to another medium, it bends at the interface. So before that, we defined something called a mu, refractive index. Which is given by speed of light in vacuum by speed of light in medium. The speed of light in vacuum is the maximum. Nothing can go faster than that. So this guy will be always greater than 1. So we simply call it as C vacuum by C medium. C is the speed of light. Yeah, they can be related. We'll see them later on in magnetism. So this is 3 into 10 power 8 meters per second. So from here, we can write the speed of light in a medium is C vacuum by mu. So few things here. So the wavelength in a medium is the wavelength in vacuum by mu. So whenever a light goes from one medium to another medium, what doesn't change is frequency. Meaning, think of like this: frequency is simply number of waves per second. If 10 waves enter, then 10 waves have to come out. Frequency does not change with medium. We will talk about this in waves also, but and color of light also depends on the frequency, not on wavelength. That's the same reason if you put a bulb inside the water, when you stand outside, it still looks the same color. The color of the bulb doesn't change because the frequency is same. So color depends on frequency, not on wavelength. There's a few points there. All clear with this? Now, in refraction, primarily there's only one thing, Snell's law. That's it. In mirrors, we had only one thing, I is equal to R. So now how do we, so first of all, so going to the question, why is the light ray even bending? Now, when you think about that, right, but this is a very fundamental thing. Huh? Forget about the light ray. If you want to make a turn, anything, you want, a car is going, you want to take a turn, aeroplane is going, you want to take a turn. You are walking in a straight line, you want to take a turn. The concept behind taking a turn is always the same. For example, if a plane is flying and let's say it wants to take a right turn, what is happening fundamentally inside the plane so that it takes a right turn? Yeah, the pilot will do something like right and it'll go right. But yeah, when he does that, exactly what is happening? What do you guys think is happening? He will announce all passengers, please shift to the right side. We want to go to the right hand. And that doesn't work. The plane will just get tilted, but it still goes straight. So what do you think we should do? If you're in foundation, we did this thing. So the idea was this: if you want to go to the right side, increase the power of the engines on the right and maybe decrease the power of engines on the left. Increase on the left and decrease on the right. Now what will happen? Because this side is getting more power, they will try to travel more distance. This will try to travel less distance. The only way this aeroplane can remain intact without braking, but still travel different distances if they go in a circle. Is that making sense? This is what you do every time. Next time, observe yourself. When you're walking in a straight line and you want to take a right turn, observe what you do. Your right side of the body slows down, your right leg comes to almost rest, and then your left leg swings around it. Isn't that how you walk? The same thing you do in cars also. If a car wants to take a turn, the wheels on the front, right, they're actually not connected with one rod. Both the wheels can rotate independent of each other. So if the car wants to take a right turn, you rotate the left wheel more and rotate the right wheel less. Because the left wheel is rotating more, it will travel more distance. The right wheel will travel less distance. The car will take a turn. Is this making sense? Fundamentally, this is the idea behind taking a turn. Let that be car, let that be human, let that be animal, let that be light ray. So something similar happens with your light ray. So this concept is based on wavefronts. We can actually use the Fermat principle and prove it, right? There are actually 3, 4 ways to prove this, but yeah, I'll show you this thing. Fermat principle is fine. The Fermat principle, the shortest distance term. So think of like this. So let's say this is mu1 and this is mu2. We have two different mediums there. For simplicity, let's say this is denser and this is rarer. So mu1 is greater than mu2. So light ray will travel slower in mu1 and travel faster in mu2. So the light ray, which is coming like this. So let's say this is a light beam. This is A and this is B. Now see what happens. Because you're traveling slower, by the time B reaches from here to here, because you're traveling slower, A will travel much more than B dash. Is that making sense? Now, if you try to join them, now see what happened to the light ray. The light ray was supposed to come this way. Now the whole beam was traveling this way. The light ray got bent, it got deviated. Isn't that what you studied in school? When light ray goes from denser to rarer medium, it goes away from the normal. Now, if you do little geometry here, this was your angle of incidence, this was your angle of reflection. These were 90 degrees. I didn't draw them properly. Then this angle would be I and this angle would be 90 minus r. Now, if you take the triangle here, triangle ABB dash, we get sin I is equal to BB dash by AB dash. But we know BB dash is nothing but speed of light c by mu1 into time. Similarly, if you take the triangle A dash, B dash, I didn't draw the triangle well. I should have put it properly actually. We get here cos 90 minus r will be AA dash by AB dash. AA dash is c by mu2 into time. If you divide them, you end up with sin I by sin r. This would be BB dash by AA dash, which is mu2 by mu1. Rearrange them. You end up with mu1 sin I is equal to mu2 sin r. That's your Snell's law, everyone. There, so Snell's law, right, didn't come randomly. We can actually prove it. This is actually based on something called wavefronts, which we will study in wave optics. Then we proved Snell's law. So there are ways to prove this. Another way to prove this, let's say this is mu1 and let's say this is mu2. Let's say this is A and let's say this is B. I'm not going to do it, but you can figure it out. So this is how we will say. So this is a light ray here going like this. Let this point be C and let this point be I and let this point be R. Let this distance be X. This distance will be L minus X. This would be H1 and this would be H2. And then we will say the time T will be AC by the speed of light C by mu1 plus BC, the speed of light by C by mu2. And then we do maximum minima, dt by dx is equal to 0. Minimum time, Fermat principle. You get Snell's law again. You can do this also. There is something more weird. Listen to this thing. This is pretty cool. In chemistry, did you guys study this thing? What is this? De Broglie wavelength. And did you study momentum of a photon? So light is nothing but made of particles. So if you take momentum of a photon, is given by h by lambda, right? So this can be written as hc by lambda or h into frequency. This is the momentum of the photon. So this can be written as I should use intensity, I guess, but okay. hc by lambda into 1 by c. hc by lambda is nothing but energy of the photon by c. So now what we can do, instead of treating this thing like a, light is a particle. So if you just take one photon, which is coming here at an angle I, and let's say this photon goes away like this with an angle r, the horizontal momentum must be conserved. This is kind of like a head-on collision. So the horizontal momentum will be P1 sin I is equal to P2 sin R. So the momentum will change. So this momentum will be some P1 momentum and this momentum will be some P2 momentum. Momentum is nothing but energy of the photon by speed of light, which is c by mu1 sin I, and this is energy by c by mu2 and sin R. Energy of the photon does not change because it depends on wavelength, frequency. So E by C will cancel on both the sides. You end up with mu1 sin I is equal to mu2 sin R. There, maybe we can actually use conservation of momentum to prove Snell's law. You can play around. Fermat principle, wavefront, or momentum of a photon. Arya.
सर हॉरिजॉन्टल मोमेंटम क्यों कंजर्व किया?
Because think about it, now when a ball is entering here, the force will be along the normal, isn't it?
Sir, like photon is entering like the material, so won't the materials for particles do some work, or they will apply force
Photons,
in all
there
direction,
are,
right?
they don't interact, regard. They're just a medium, right? Don't treat it like that. It is just a particle which is when you're changing from if you say that way, so when the particle was traveling only in mu1, what did these particles do? So it's not interacting with that. So only when you change from one medium to another medium, only at the interface you're getting some kind of interaction because the medium is changing.
Feels weird.
Because if you say particles and all, then the whole story will come like why didn't nothing happen here? So it's just a light is a photon, right? It is not going to interact matlab, these particles. But when you're changing the boundary, something happens. We don't know what exactly happens there, but it works. The horizontal component of momentum cannot change. Clear with this? So that's momentum thing is little out of the box, but we can get questions on this in modern physics. We can mix up things like this. And then, all this standard stuff, mu1, mu2. If mu2 is greater than mu1, so this is rarer and this is denser. Now here, I want to tell you something here. What is rarer and what is denser? This is important. So a light ray entering here at an angle I will get closer to the normal. So when a light ray goes from rarer to denser, it gets closer to the normal. Great. We will finish all the introduction today. Next class, we'll do some really good problems on this. Now, if you go from denser to rarer, we will talk about what is rarer and what is denser. In this scenario, the light ray goes away from the normal. This you studied in school. But now, if you keep increasing the angle of incidence, something happens. If you hit this at a particular angle called theta critical, the light ray becomes parallel to the incline. So this theta c is critical angle. And how do we calculate this? Mu1 sine theta critical. Basically, r becomes 90, mu2 sine 90. So sine theta critical is mu2 by mu1. Do remember this. What happens if you exceed this angle? Now, if you increase this angle, it starts behaving like a mirror. The light ray simply bounces off. So if your I is greater than theta critical, the ray bounces off. There'll be no refracted ray. It kind of behaves like a mirror. This phenomena is called TIR, total internal reflection. Did you all study that term? Must have heard it in school or somewhere, but yeah, total internal reflection. In case you don't know that, all clear with this. Now, this is an important discussion. You can get some good, really theoretical questions on this. How do you know whether a medium is rarer or denser? It depends on what. When you hear the word denser and rarer, be careful. They're not talking about your density. We call this thing optically denser. So the word is that you should say optically denser. A medium is said to be optically denser if the speed of the wave is more. Same way, the medium it is said to be optically rarer if the speed of the wave is less. So, optically denser is it depends on the kind of wave you're sending. For example, say if you're sending air and water, and if you're sending a light ray, where does light travel faster? Air or water? It travels faster in air and slower in water. So that means air is a rarer medium for light, and water is a denser medium for light. So this light ray will go towards the normal. But same thing, if you do it for a sound wave, again the medium is still same, huh? Air, water only, nothing changed. But where does sound travel faster now? Sound travels faster in water. So water becomes rarer medium and air becomes denser medium. Even sound obeys principle of refraction. So if you send a sound wave, so even you can have TIR in the sound wave. So the sound wave will actually go away from the normal. Are you clear with this thing, everyone? So don't blindly say air is always denser, air is rarer, water is denser. It depends. What are you sending? Are you sending a light wave or a sound wave? So it can be a very simple question. A sound wave is sent from air to water. What happens? Will it go towards the normal or away from the normal? You will think, oh, water is denser, but for sound, water is rarer. Is this clear, everyone? So that's the thing there. And then this is how things would look like. Look at this experimenter. So there we have that semicircular thing, and you're shining a light beam. You can see when you're sending it straight, for a circle, the normal is passing through the center. So initial I is 0, so it's going straight. Now, as you keep changing it, now understand here, where is the refraction happening here? Refraction is not happening on the curved surface, it is happening on the flat surface, isn't it? When the light ray enters the curved surface, it is entering along the normal. On the flat surface, the normal is straight, but now you're having I and R. Now, as he's rotating, the bottom angles are incidence, the upper angles are refraction. Here you can see when he is at roughly 20, this is I is equal to 20 and R is, I think it's already crossed 30. So you're going, the glass is a denser medium, the air is a rarer medium. It's going from glasser to air, so it's going away from the normal. Now, if you keep increasing, the ray is going away from the normal. You can see there's almost a refracted ray is already coming out. There's a reflected ray. You keep pushing it more. I think somewhere at 40, 42, there it's gone. There is no refracted ray. Observe that on the other side, there is some shining and all, that is dispersion, but you don't have a ray. Everything is getting reflected. This is TIR. And if you increase the angle further, you can see it is behaving like a mirror. All the light rays just bouncing off. Clear with this? That's how it looks.
Welcome to Moo Rapid Science and how light and open incident.
There. Remember, if you send a parallel beam into a concave mirror, they meet. Where is this? The 4 special light rays we're talking about. See. Now see, how do you find the principal axis? Remember, if you send a light ray along the principal axis, it will come back along the principal axis. So you switch it on the middle one, and by moving it, you can adjust it. Somewhere you're hitting on the principal axis, you can. That's your principal axis, basically. I'll post this in the group. You can check it out more arams. If you put multiple rays, what happens? There, can you see how they're meeting? That's your focus. If you send a parallel beam, they meet at a single point. So he's showing all that stuff and everything. Look at this thing. Concave mirror, the experiment which you showed, some materials required. They have a screen, so paper thing. We have a concave mirror. So P is the pole, F is the focus, C is the center. You already calculated the distances and marked it on a paper. So there, you kept the mirror at the pole. Case 1, object is very far. So you kept the candle little far. Can you see a small dot? It's not really at infinity, so you can still see a small image. There, if you switch off the light, you can see. Can you see that candle light? Small white spot, inverted. So the image forms at the focus, inverted and diminished. So that's an image on the screen there. So light rays go and they meet at the focus. Real inverted, diminished. Object is beyond center. So you kept it close to center, but still beyond center. There you can see the image a little bigger. You can clearly see the candle image. That's how it looks. Image is inverted, still diminished, but it's a little bigger. between focus and center. Object at center, you can see image is exactly on top of it. So here the object is not on the principal axis, so there is a difference. Object is at center, image will form at the center. Object is between center and focus. Now image will be inverted still, magnified beyond center. You can see it as big flame. If you keep the object at focus, image will be at infinity. So you have to keep the screen a little far. There you can see some kind of light there. It's pretty large. It's scattered. There you can see the image. This is the object at focus, image goes to infinity. Object between P and F. This is the only case in concave where you get a virtual image and direct and magnified. So you can actually see nothing on the screen there. That is just some reflected light, so that's not an image. Where is the image? The image is inside the mirror, see? That's virtual. So you can see the image more clearly inside the mirror. So the object is virtual, magnified, and everything. Yeah, it's a good one. You can definitely check this out. This thing is an optical cable. So I'll show you in the next class. This is convex lens. Because convex mirror is hopeless. There is nothing there to show you actually. Fun. This is a good one. We'll do this in the next class though. So you have a glass lab, you got a laser. Can you see how the light is bending inside? You can clearly see the light is bending. It goes straight, bends, and then it comes out. That's your refraction. So there. So that's few things there. Okay, with that, we'll wrap up for the day. We will continue again on Thursday. So Thursday, when we catch up, we will do refraction on plane surface, and then we will do refraction on curved surface. So we will play around that. That's next class. Mostly we'll do apparent depth and all that stuff. And then maybe a little introduction on the curved surface part is a pretty easy one. So I think we should be able to wrap up this in another 3-4 classes. We will also finish off optical instruments also. So we will finish off everything in one go. But the mirrors part is done. If someone wants to start solving, you can start solving. You can finish off every mirror problem. If you go to my booklet, in that booklet, if you see, questions are segregated subtopic wise, mirrors, lenses, and all. So you want questions only on mirrors, you can get it from the booklet there. Okay, with that, we'll wrap up for the day. I'll see you guys again on Thursday, same time. And do remember, there's a test online on Friday. Make sure to give it. So any doubts, anything else, please stay back and ask. I'll be free to leave.